Stars. Big balls of light sitting in a so-called empty space. They're like Cotton Eye Joe. Where do they come from? Where do they go? Stars go through a natural cycle of life, just like humans. They come in a variety of masses, which determines the brightness and how it dies. The larger its mass, the shorter its life cycle. That mass is determined by how much matter is available in its nebula. A star originates from this gas cloud. Over time, hydrogen is pulled together, and it starts to spin, and it keeps contracting and getting hotter until the pressure balances the force of gravity. When the gas particles in the gas cloud run into each other, heat energy is produced. The result of this is a small clump of molecules called a protostar. The protostar enters the main sequence phase of life when the core temperature reaches the point for fusion to commence. The protons of hydrogen are turned into atoms of helium. Once the hydrogen supply runs out, the star's core becomes unstable and it begins to collapse. The outer shell of the star is still mostly hydrogen, so it begins to expand. As it is expanding, it begins to cool down and glow red. It has now entered its red giant phase. It's called red because it is cooler than when it was a main sequence star, and it's a giant, well, because it's giant. In its core, helium fuses to carbon. And as the red giant is expanding, it can swallow up whole planets. Red giants can be 20 and 100 times size the sun, though only contain 0.25 to 8 times the mass of the sun. Eventually, as the outer layers of the star expand, gravity causes its core to shrink and contract. The temperature and pressure in the center increase until nuclear fusion can start again. Now the core is fusing helium rather than hydrogen. All stars evolve in the same way. It's when it gets to the red giant phase that the mass decides which life path it will take. After the helium has fused into carbon, low-mass stars collapse again. As the core is collapsing, the outer layers are expelled and it remains as a white dwarf, which will later burn out into a black dwarf. High-mass stars, however, will undergo a supernova. If the explosion is 1.4 to 3 times more massive than the sun, it will become a neutron star. A neutron star is a very dense star. The enormous density of it means a teaspoon of its material would weigh 10 million tons. And they can get as small as only 10 miles across. Its core has such a strong gravity that most of the protons and electrons combine into neutrons, thus giving it its name. If the star's core is 3 times more massive than the sun, it'll do something different. So much gravity will be produced that the core will be swallowed up by itself, thus creating a black hole. A black hole is a place in space where gravity pulls so much that even light can't get out. You may think that the black hole just sucks up everything in its path, but boy are you wrong. Yes, it does suck things up, but you would have to be very close and in its range to be sucked in. If you do somehow, some way get sucked in, you'll become an Italian's favorite person. Why? Because you'll get spaghettified. Yummy. It's painful, but lucky for you, you'll be dead within less than a second. A quick summary of a star's life cycle would be it starts out as a star-forming nebula, or just a nebula. And the gas and dust particles swirl together by the force of gravity and clump together to make the protostar. The protostar slowly becomes hotter, and once it's hot enough, it can start fusion, where hydrogen turns into helium. Eventually, the hydrogen supply will run out and the star's core will become unstable and it will start to expand. Now it is a red giant and is converting helium into carbon. Once the helium supply runs out, it begins to squish down again into a white dwarf. And depending on the mass of the star, it can either keep burning out into a black dwarf or it will go into a supernova. After the supernova, it will either become a neutron star or a black hole depending on its mass.